Hey guys, these notes are for vertex form and transformations. The second video goes over the transformations in vertex form, so this video is going to primarily go over just vertex form and going from vertex to standard form and standard form to vertex form. Alright, so our essential question is, how is the vertex form related to transformations, and how can we write equations in both forms? Alright, so the lesson previous to this we learned about standard form. Now standard form, remember, is y equals ax squared plus bx plus c. Okay, now standard form isn't super useful. Vertex form, however, is more useful. Just like how when we had linear functions, standard form wasn't really useful to us, the ax squared plus by equals c, but point slope and slope intercept were more useful to us. So vertex form is something new. This is y equals a, and then in parentheses, x minus h squared plus k. Now I know that looks scary, but I think ax squared plus bx plus c looks scary the first time you saw it too. So I promise it's not as scary as you think it is. Okay. Now, let's use yellow. Now, obviously we need an input and an output in every single equation that we have, because for every function we need an input so that they can output something. So of course both equations are going to have x and y. Now, what's one thing that you see also that is similar? What variable do they also have in common? Okay, they also have the a in common. So, important to note that the a in both equations, or in both forms, are the same. Okay, so if a in standard form is -3, then a in vertex form is also -3. So whatever the a is in one, it is also a in the other. Okay, now, do you remember slope-intercept form, y equals mx plus b? Okay, this gave us the slope and the y-intercept, right? And it's called slope-intercept form. The name tells us what it gives us. So if I have vertex form, what do you think it gives me? It's going to give me the vertex. Now the vertex, remember, is your highest or lowest point. Now the vertex is represented by the point h comma k. Now normally we would have a point that's just x comma y, but since the vertex is super special on our parabola, it's given its own letters, so it's h comma k. Now, do you see how the h is located inside the parentheses with a minus sign? Now that minus sign tells me that my h sign is going to be the opposite of what I think it is. So this will be the opposite sign. Okay, but whatever k is, it'll stay. So for example, if I have x plus 3, then h is going to be -3. Okay, it's always going to be the opposite sign. But whatever k is, k will stay exactly the way it is. All right, so let's go ahead and practice this. We're going to identify the vertex and the axis of symmetry. Now, remember, it's called vertex form because it clearly gives us the vertex. We don't even need to graph to find the vertex. So let's look at number 1. I know that vertex form is this, so I'm going to go ahead and write that down. And I know that my vertex is h comma k. Okay? Now, what is my vertex in this problem? Let's use a different color. Let's use pink. Okay. Well, h in here is -4. So when I take it out, it's going to be the opposite sign. So it's going to be +4. And then my k will stay exactly the same, which is +3. And remember, axis of symmetry always starts as x equals, because it goes through our vertex. And our x value for the vertex is 4. So it's x equals 4. Now, would this function open up or down? This would open up because our a is positive. Our a is a +2. So a is positive. Whoa, okay. All right, next one, we have a new function. So let's go ahead and identify our vertex here. Remember, h is going to be the opposite sign when you take it out. So instead of +2, it is now -2. And then your k is still going to be -1. Okay? Again, you don't need to graph. Vertex form gives you the vertex, so you should know it without even having a graph. Axis of symmetry starts with x equals, and it is the x value. Go ahead and highlight these so that you remember where these come from. Okay? Now, will this open up or down? This will open down because my a value is negative. Do you see that negative sign there? Okay, so a is negative. Last one. Let's look at our vertex. Our vertex here is going to be -2, +4. Okay, remember that h value is opposite. And our axis of symmetry will be x equals -2. Okay, this will this will open down because our A value is negative. So A is negative. A lot of cars honking today. Okay. All right, so that's just some practice identifying your vertex and axis of symmetry. The axis of symmetry part is kind of review from last time, so that shouldn't be a surprise as to why it's x equals. All right, so here's one thing that's super important to know how to do. We need to go from vertex form to standard form. So from vertex form, remember that's y equals ax minus h squared plus k. Standard form is y equals ax squared plus bx plus c. Okay, and I want to go from one to the other. All right. Now, just looking at these, what differences do you see? Well, obviously, one has hk, but what does vertex form have that standard form doesn't? Okay, vertex form has parentheses. We need to get rid of those parentheses. And so when we see number 1 here and we want to get rid of those parentheses, you're going to be like, oh, let's distribute. Now, here's my thing. Don't write it. So just go ahead and observe. If I have 2x and I have 2x squared, right? I can distribute this, and I have 2 squared times x squared. What's the operation that's happening between 2 and x? Multiplication, right? But if I have, let's say, 2 plus x or 2 minus x, okay? Let's just say I have either case here. In either case, since there is not multiplication happening, if it's addition or subtraction, I must write it twice. So this one would be 2 plus x times 2 plus x, right? Because it's 2 plus x squared. I have it twice. Or I would have, if in this case, if there was a minus sign in the middle, I'd have 2 minus x times 2 minus x. So the important thing here is that you must write it twice. You cannot distribute. If you distribute, nothing will be correct. So I'm going to write this twice. Okay? So everything will stay the same, y equals 2, but I'm going to write the x minus 3 2 times, okay, because it's being squared. Now again, our goal is to go from vertex to standard, so I'm trying to get rid of those parentheses. Okay, next we are going to double distribute. So we have x times x, which is x squared. Now these are still going to be in parentheses when we're finished. So x squared, x times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Okay. Again, everything else has stayed the same. I haven't changed anything, so everything in pink has stayed the same from the beginning. The only thing I've done is I've written my parentheses twice, and I've double distributed. Now I'm going to look for like terms, and I have 2. That's going to give me 6 or negative 6x. So I'm going to go ahead and write that. X squared minus 6x plus 9. Okay. Now the reason why those parentheses have stayed out there is because this 2 in the front is being multiplied to the entire expression inside. I can't just pretend like the parentheses drop and only multiply the x squared by it. I have to multiply the 2 to everything. So at this step, I'm going to distribute the 2 to all 3 terms, every single term that's in the parentheses. So I have y equals 2x squared minus 12x plus 18, and then I have the minus 4 that's been there this whole time. And then I look for any like terms. I have these two guys. So I have y equals 2x squared minus 12x plus 14. Okay? Is that in standard form? Ax squared plus bx plus c? Yep. So I am done. Okay? Now, this is your opportunity to go ahead and try number 2 on your own if you think you got it. Same steps apply. The first thing you're going to do when you see vertex form is you're going to write the parentheses twice. Okay? X plus 1, x plus 1, minus 2. Double distribute, x squared plus 1x plus 1x plus 1. Again, everything stays the same. That 3 is going to stay out there. It's not going to be distributed yet. I have some like terms. Come on, okay. 1x plus 1x is 2x. Remember, if you have one apple plus another apple, you have 2 apples. Okay, all of that has stayed the same, and now I'm going to distribute to all 3 terms inside. Whoops. 3x squared plus 6x plus 3 minus 2. Now my like terms are in the back. 3 minus 2 is going to give me 1. So I have 3x squared plus 6x plus 1. Now, if you ever want to check to see if you did this correctly, you can always graph the first function, the first equation, and the last equation that you get, the standard form and the vertex form in your calculator, and you will get the exact same table when you go to second graph. Or you'll just look at the graphs and you'll see them overlapping each other, okay? Now, this one's going from standard to vertex form, okay? So when we're going from standard to vertex form, so y equals ax squared plus bx plus c, and we're going to y equals ax minus h squared plus k. We're going from one to the other again, but we're going the opposite way. So we're going from something that doesn't have parentheses into something that does, okay? Now, to help us out with this, to help us find the vertex, we're going to use the axis of symmetry formula, okay? And we did this sort of in the last notes when we use the axis of symmetry to find our vertex. So the axis of symmetry formula, that is going to be x equals negative b over 2a, okay? So the first thing I'm going to do is I'm going to identify my a, b, and c. So my a here is 3, b is negative 12, and c is 1, okay? Now, using my axis of symmetry formula, I have x equals negative 12, because that's our b, over 2 times 3. Negative 12 is positive 12 over 6, which gives me 2. So x equals 2. That means my axis of symmetry is x equals 2. Now, knowing that my axis of symmetry goes through my vertex, I already know that my vertex will have the same x value. So I know it's going to be 2 comma something. I don't know the y value part yet. So now I'm going to find that part out. Okay? Now, I'm going to go ahead and remember, we rewrite the equation. If you don't really want to, you don't have to, but I always like to rewrite it so I can see it. And in order to find y, I must plug in my x, since I know x equals 2. So I'm going to plug in a 2 here. I'm going to plug in a 2 here, since I know it's 2. So I have y equals 3. Then I have 2 squared minus 12 times 2 plus 1. Anytime you plug in, you must use parentheses, okay? That will help you to not make mistakes. If you're an on level, go ahead and just push this in the calculator. You can type this part in your main screen and it should give you a number. But if you're in pre-AP, you do need to work it out by hand. Okay, so we have y equals 3 times 4 minus 12 times 2 plus 1. Actually, I don't know why I didn't just do that. 12 times 2 should be negative 24. Okay. Then we have y equals 12 minus 24 plus 1. Again, if you're on on-level, you should just be able to punch this in the calculator. 12 minus 24 is negative 12 plus 1. So y equals negative 11. Okay. Now, what is a negative 11? That's my negative 11 in my vertex. That tells me this number here. Okay. So I know that my vertex is 2, negative 11. Okay. And I know that I need to put it in vertex form because I need to go from standard to vertex. So that's going to be this. Okay. Oops, I don't know where that parentheses came from. Now, obviously, I know vertex. Remember, what variables represents our vertex? That's going to be h comma k. So I'm going to plug my vertex into my vertex form. Now, remember, every equation, every function has an input and an output. So you need to keep the x and y there. So these guys will stay the same. Nothing will happen with these guys. These will always be there. Now, my h in my vertex is 2. So when I plug it in, it's going to be minus 2. And then my k is going to be negative 11. Now, the only variable I haven't put in is a. Now, remember, a in both forms are the exact same. So what was my a in number 1, or in this problem? My a was 3. So that's what I'm going to plug in over here. I'm going to plug in a 3. Okay? And so that is my vertex form. My vertex is 2, negative 11, right? Opposite sign. And then the a will be the exact same number it is in the beginning. All right, go ahead and try the second one on your own if you feel pretty comfortable with this, but it's the same process. Use the axis of symmetry formula, find the vertex, and then plug the vertex and the a value in. Okay. Number 2. Identify my a, b, and c first. A is 2, b is 12, c is 14. X equals, I'm going to use my axis of symmetry, that's going to be negative 12 over 2 times 2, because my a is 2. Negative 12 over 4 is going to be negative 3. So I know the axis of symmetry, x is going to be negative 3. Now, that means my vertex will have negative 3, and I need to find the y value. Okay? So I'm going to plug in y equals 2x squared plus 12x plus 14. Anywhere I see a x, I'm going to plug in negative 3 since I know that x is negative 3. So I have y equals 2 times negative 3 squared plus 12 times negative 3 plus 14. Again, if you're in on level, you can go ahead and plug that in the main part of your calculator, and it will calculate that for you. But if you're in pre-P, here we are, simplifying this. Negative 3 squared is positive 9. 12 times negative 3 is negative 36, and then that's just plus 14. Y equals 18 minus 36 plus 14. And then 18 minus 36 is negative 18 plus 14. And then y equals negative 4. So that means that in our vertex, we have negative 3, negative 4. That's our vertex. Now, I need to plug that into my vertex form. Y equals a x minus h squared plus k. Okay, I know that my vertex is negative 3, negative 4. So this is my h value, and that's my k value. So we have y equals x plus 3. Remember, signs are going to change when you plug them inside. Our h always changes, but k stays the same. So it will still be negative 4. Since it's outside the parentheses, it will do what you would normally put down. And then remember, our a value is the same as what we started with. So our a value was 2 in the beginning, and it is still going to be 2 here. So that's my vertex form. We went from standard to vertex in that one. Okay, that one does require more work than vertex to standard, but you're basically just doing the opposite thing but backwards. I mean, backwards, I guess. Opposite thing but backwards would be like a double negative. Anyways, all right, this is the last section of just the vertex form notes. So only 2 problems left. I left a lot of room on this, not knowing that you don't really need that much, so enjoy the very much space that you have because you don't really need it, to be honest. All right, so we need to go and write the equation in vertex form. Now, vertex form, again, is this up here. A times x minus h squared plus k. So we're given a vertex and a point on the parabola. Now, what is a parabola? That's the U shape created by our quadratic function. Okay, now vertex is represented by what 2 letters? H, K. And a regular point, any point, is represented by x and y. Now I know, again, that I need to write it in vertex form. Okay. Is it possible for me to plug in the h and k and the x and y into this formula, or into this form? Yeah. So let's go ahead and do that. So I know, what is my y going to be? So we're going to start on the left side first. So y. Our y value is negative 6. Okay, that's going to stay the same. Okay, and I know equals. Now I don't know a, right? So I don't plug anything in for a. Do I know my x value? My x value is a 1. I'm not really sure why I wrote this in green. Let me change that. It should be negative 6. All right, so the x and y points are in red. Okay, and now do I know my h? My h in my vertex is negative 1, so when I plug it in, it'll be positive 1. Okay, and then my k value is 2, so that would be plus 2, positive 2. Okay, so I match the colors. So my vertex is in the green, and my point is in the red. And then the blue part is just what I don't have filled in. So what variable do I not know? I don't know my a. I'm solving for a, basically. Now, from this part, you just simplify. Now, inside your parentheses, you're like, well, Miss Bowie, I have to write this twice because it's squared. Well, I'll be like, well, no, not really, because can't you just add 1 plus 1? Then, yeah, you can add just 1 plus 1. So what would you get? You get 2. So you have 2 squared plus 2. Okay, and then from here, you just simplify like normal. 2 squared is going to be 4, so you have a times 4 there. Okay, and I want a by itself. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So I have negative 8 equals 4 times a. Remember, a times 4 and 4 times a are the same thing. Divide both sides by 4. So I have a equals negative 2. Okay, now I've solved for a, but I need it in vertex form. So let me go ahead and write my vertex form again. Okay, I know my a value, so I am going to plug that in for my a. So I have y equals -2. Now, again, every function needs an input and an output, so my x and y should always be there. They should always be present, okay? But I don't know my vertex. Oh, I do know my vertex. I need to plug in h and k. I know my h is supposed to be +1 when I plug it in, and it's going to be +2 on the outside. So the only thing that's different is your a value. You're solving for the a value, and then you keep your vertex in because you do need a vertex for the vertex form, okay? But yeah, that's how you do number 1. If you feel confident, go ahead and try number 2. Same process. Identify what variables your vertex and point are. You're going to plug everything into vertex form and then solve for a. Okay, so let's go ahead and write our steps. We're going to solve for a. And then the second part is you plug in a, h, and k into vertex form. Okay. So let's go ahead and do that. We know our vertex is going to be hk, and your point is xy. All right. So we have y equals a x minus h squared plus k. Okay, I know that my y is 4. I don't know my a. My x is 4. My h is a 2, but when I put it in, it will be a -2. Square. Don't forget the square. That's so important. Remember, it's a quadratic, so there has to be a squared somewhere. And then your k value is -4. Okay? So I went ahead and I plugged all my variables in. I plugged in h, k, x, and y. The next thing I'm going to do is I'm going to simplify. Well, 4 minus 2 is 2 squared. So that's going to be 2 squared. So everything stays the same. I just simplified what's in my parentheses. Okay, and then I know that 2 squared is 4, so that's going to be a times 4 minus 4. Okay, now I need a by itself. So the first thing I'm going to do is I'm going to add 4 to both sides. Since it's negative over there, I'm going to add 4. 8 equals 4a. Divide both sides by 4. A equals 2. What do I do from here? Well, I plug it into my vertex form. You don't have to write vertex form multiple times like I am. I'm just doing it because so you can see what I'm plugging in, because I have to zoom in so I won't be able to show you. All right, so we have y equals, okay, 2 is our a. We have to keep an x there. What is our h? So our vertex is 2, -4. So when I plug it in, my 2 will be -2. And then my k was -4, and it's still going to be -4 because it's outside the parentheses. All right. So those are the last 2 problems given a vertex and a point on the parabola. You need to be able to write vertex form, but that is it. You should be able to do that, convert from standard form to vertex form, convert from vertex to standard, and then just be able to identify your vertex and axis of symmetry, and also tell me why it opens up or down. But that is it for your vertex form notes, and then the second video will be over